Good afternoon, everybody. Thank you, Sean. First off, I'd like to thank you all for choosing to attend Top Tips in Getting 3D Ready out of the many other fantastic presentations that we have prepared for you here for today. What we'll try to achieve in the next 20 to 25 minutes is to get your organizations 3D enabled or at least get them 3D ready. So my name is Sarah and with me is my colleague Tibu, and together we will try to be your tour guides in this journey to 3D. Now, why do we need to go 3D? 3D, in as much as we would like to stay with 2D, especially with the advanced technology and improvements that we have in smart mapping, such as in ArcGIS Online and even in ArcGIS Pro, there are simply some items or some problems that 2D mapping cannot solve. So with that, there are better viewed and solved using 3D visualization and analyses. Also, us being humans, we are naturally visual beings. And if we would see a specific item, a specific scenario as closely to how it looks like in reality, then it not only adds a dash of fancy into the view of the problem or the scenario at hand, but also it improves our understanding greatly because we can much more relate to it in a clearer context. And furthermore, with a clearer story of the scenario at hand, stakeholders can better communicate and discuss certain factors and solutions to solve the problems that they are facing. And hence, in totality, 3D tells a better story. Now, how does one become 3D ready? We have actually narrowed this 20-minute session down to two key points. First is 3D technology, and second is 3D content. So I will be guiding you out through the 3D technology portion, and then later on in our demonstrations, Tibu will be focusing on the 3D apps and the possible contents that you can work on that you can start off with. So maybe here are some questions that you can start asking yourself or pitch within your organizational meetings whenever you would return back into your offices. Number one is, what types of data format can I make use of in terms of 3D data? Or if you're still in 2D data, what are the specific workflows and which ArcGIS applications or products should you make use of to start converting these 2D information into 3D visualization or 3D data? And then finally, what specific extensions or applications can you further develop to help aid your conversion and to help aid your organization becoming 3D enabled? Right, so let's move on and let's try to answer these questions individually. 3D has massively moved on from becoming something that is really nice to have within your organizations to something constant and vital in our systems and within our workflows, especially when we are trying to communicate something. Now with that, I am pleased to inform everyone that Esri now has the capability to serve 3D across the platform rather. So what does exactly that across the platform mean? That means anywhere in any environment that you are working on, be it your desktop applications, your web scenes within your web browsers, or even your mobile applications, all of these platforms can access Core 3D capability. So accessing and making use of Core 3D capability within these three different platforms is now possible. Let's start off with the main star or the main platform, which is the desktop platform. So we will be focusing on two applications, namely your ArcGIS Pro and your CityEngine. So these two applications, the latest versions or releases of them have been released to the public in July of this year. And before we proceed with the specific highlights or the notable highlights for each application, let me post a question for everybody in this room. Actually, I myself have asked this question before. When can I use or when should I use ArcGIS Pro and when should I use CityEngine? So does anybody here have asked that question as well? Although maybe ArcGIS Pro is is fairly new to everybody here, but CityEngine has been around for quite some time. But since they are both being catered or since they are both being packaged as 3D applications in the desktop platform, when can we actually make use of these two? So let's clarify that within this session. ArcGIS Pro is the main 3D application or the main 3D software. So if there is anybody here who is still using ArcScene or ArcGlobe for maybe working with your local or your global scenes, I urge you to start using ArcGIS Pro because it has a multitude of functions and workflows that fares greatly over both ArcScene and ArcGlobe, especially in 3D visualization. And I think the most notable factor in shifting to ArcGIS Pro is that you can work with both 2D and 3D within the same application and within the same viewport. Right, so that clears it up for ArcGIS Pro. Whereas for CityEngine, anybody here who is working in urban design, urban planning? So I see some people nodding their heads. So if you particularly are in that sector, if you're working in urban planning and design, then I suggest that you use CityEngine for that, because CityEngine is actually designed to have specific tools and functionalities that caters or that gears towards those specific functions for urban design, for 3D texturing or for interactive 3D manipulation for your multi-patches and seamless 3D editing. Then I suggest you use CityEngine for that. But again, do not keep in mind that CityEngine is only for urban design. Everything else should go to ArcGIS Pro. If you are keen on developing your own CGA rules, if say for example you would like to develop your own textures for your buildings and maybe design animations such as what has been shown in the user conference in San Diego. So they've actually showcased Zootopia, wherein they used CityEngine to create the different animations. So you can also make use of that particular software in that sector or in that industry. Right, so as mentioned earlier, both Pro and CityEngine 2017 have been released in July of this year, July 2017. And here are some notable features for Pro. Okay, so let's proceed with Pro first. So you can see two different animations playing around on the screen right now. The one on the lower portion of the screen is what we call our on-screen navigator. So it allows the user to capture specific camera views, be it above ground or underground, within a single widget that is inside the application. So you don't have to toggle on your mouse with the ribbon on top or navigate through your maps. You can simply make use of that widget usually found on the lower left-hand side of your screen to navigate through your scenes seamlessly. And the great thing about this is it works in both 2D and 3D, and you can place it wherever part of the screen that you are most comfortable with, right? And a personal favorite of mine, which is still available in the 2.0 release of ArcGIS Pro, is the dynamic view linking for 2D and 3D, which is the other animation showing on the screen. So you can simply add in, if you already have pre-created MXDs, 2D data, 2D layers, you can add them within a Pro project along with a 3D scene, for example, and then you can link the two views together so that whenever you navigate or pan through or fly through specific areas within your screen, both areas will be zooming in accordingly, or dynamically rather. Right, so in terms of 3D editing and modeling, ArcGIS Pro 2.0 offers true editing workflows as it now supports snap to scene layers. So we are quite familiar with snapping for 2D, but now we have snap to scene layers for you to be able to work seamlessly and edit seamlessly within your 3D datasets or within your 3D interface. You can also apply procedural rules on your 3D objects, and data formats such as OBJ and DAE are both supported within ArcGIS Pro 2.0. Right, so those are some of the notable improvements or highlights for ArcGIS Pro. Moving forward for CityEngine, these are the, I would say, top 3 most requested functionalities for CityEngine 2017. So first up, let's check out the one on top, which is 3D Measure, which has been, I think, on the top of the most awaited and most asked for function in CityEngine. So now you can measure horizontally and vertically within your scenes or scenarios. Next is your context queries functionality. So as you can see, I can specify a behavior on an object. In this case, I have a tree that I can move around within the fence. And in terms of the behavior, as I move the tree around the fence, it becomes quite aware of its surroundings. So it automatically zooms in or zooms out, and it automatically adjusts or rescales its size according to where I would place it within my fence. And then finally, what I would say is the coolest addition in terms of the functionality in CityEngine 2017 is called scenarios. So with scenarios, you can link specific scenes or scenarios within one CityEngine document. And with that, you can also link specific dashboards with them. And what's nice about this is not just with the comparison between one scenario and another, whenever I would edit a particular object within my scenario, as what's happening here in the video, the benchmarks and the values in my linked dashboards also adjust dynamically. So I don't need to adjust my scene and then adjust my dashboards accordingly. As long as they are linked together, one edit on one portion, the edit is already applied on the other as well. So I think that is pretty great. All right, so since we are trying, or we have mentioned earlier that 3D is covered across the platform, so we've pretty much covered desktop 3D, let's proceed with apps. So it's quite good that ArcGIS Earth has been demonstrated earlier, so we'll have another demo later on in our session, which uses different data types. As for the apps, the specific applications wherein you can use 3D functionality or work with 3D functionality is, of course, ArcGIS Earth, which is free, as mentioned earlier, and enables you to make use of KMZ files in case you already have them within your organizations. Next is drone to maps. Say, for example, you would like to create your own flight path and maybe start creating your 3D meshes. So with drone to maps, if you already have the point cloud data or point cloud information, you can easily convert those big data into 3D meshes so that you can make use of them within your web scenes and then publish them in your portal or in your ArcGIS Online. And then finally, I would like to highlight Web App Builder, which requires not a single line of code. So for those who are not particularly confident within their coding skills, you can still make use of Web App Builder to quickly create your 3D applications nicely. Okay. Now, as for the enterprise, I've just mentioned ArcGIS Online and Portal for ArcGIS. 3D services are also offered within the enterprise platform. And you can make use of your integrated meshes, your point clouds. You can publish them and then have them as scene layers within our 3D web scene viewer. Also, 3D smart mapping is now available, which allows for creation of more appealing web scenes. So I found that working with 2D smart mapping in ArcGIS Online has greatly or massively improved the creations of story maps, of web maps across different areas of the globe. So I would like to hope that that would be the case for 3D smart mapping as well. And then we have the developer tools. So if there are hardcore developers inside this session right now, I am pleased to inform you that runtime for iOS, for Android, your .NET and your JavaScript API are all supported or all supports 3D capability, core 3D capability. So you can hard code and you can create your customized applications using these four SDKs and APIs to create your 3D applications accordingly. Now, that concludes the 3D technology part of our session. And to further showcase the different applications of these technology at hand and maybe shed light into the 3D content and templates available for us here to make use of, let me now pass the floor over to Tibu.
Thank you, Sarah, for introducing the 3D apps across the platform. Thank you, everyone, for being here today. So to create a realistic and immersive 3D experience that model our world, cities, buildings, and infrastructure, there's a couple of data layers we need to prepare. So first of all, we'll need a base map in our 3D scene. So like in a 2D map, we can choose from the multiple Esri base map, like the satellite imagery or the topographic base map. And to make our scene more realistic, we're going to add a terrain. Oops. So we're going to add a terrain, also called an elevation layer, to simulate the surface of the Earth. Of course, you have the possibility to use your own base map and your own elevation layer. So mountains, canyons, cliffs, although we don't have many of those in Singapore, but we have hills, like in Bukit Timah, Jurong, Fort Canning, Mount Faber. We have canals and rivers, and all these objects participate to form the elevation of the ground. Now that we have our 3D base map, we need to capture natural and man-made infrastructures, and there are many technologies available to help you do that. LiDAR uses pulse laser to measure distances and generate point clouds. Other technologies are capable of turning georeferenced images into 3D models, like drone to map, for example. And data can be collected from satellite, from planes, drones, from mobile and static ground scanning systems. And according to the collection method, you'll obtain 3D models in different data types. So one popular data type is point cloud, which we use in ArcGIS for visualization, analysis, and to derive other 3D content, such as elevation, building, roof shapes, and more. So here we are seeing the result of a point cloud layer over the city of Rotterdam in the Netherlands, which has been published from ArcGIS Pro to ArcGIS Online. So in the next example, the data collected have been shared as an integrated mesh layer. So a mesh can be described as the skin of the Earth that includes the ground and all the above ground objects. So creating a 3D mesh model can be fully automated, which allows for quick visualization and is very suitable for inspection. So here is another scene of the city of San Francisco with detailed textured buildings created from pictometry and published as a 3D object layer. So in this case, each object is a feature that is defined by its own geometry and attributes. So in addition to capturing data, we've all spent years, decades, sometimes more, to create highly accurate and updated database of rich 2D data. And so let's use it, because your existing 2D data are valuable even in a 3D context. So 2D and 3D data can be combined to solve problems like this public transport accessibility scene. And in fact, by running a couple of geoprocessing tools, we can turn our 2D features to georeferenced 3D models. So this sewer network, originally modeled as point and line, has been easily converted to 3D. And of course, I have to talk about BIM. And in addition to telling you, yes, you can bring your 3D models and attributes created by BIM software to ArcGIS. I'd like to re-emphasize something. I'd like to re-emphasize that BIM is not a software, it's a process, and that GIS definitely has a role to play in this process. Because a building or a piece of infrastructure does not live by itself. It is highly interdependent with its surrounding, and understanding spatial relationship is one of the things that GIS does very well. So I just gave you an overview of some of the many types of data we can use with ArcGIS for visualization and analysis. And all of these layers can be shared online as scene layers. So there's something I'd like to tell you about scene layers. The scene layer is based on an open specification designed by Esri. And this specification is designed from the ground up to be web, mobile friendly. And as we have seen, it enables streaming of large 3D data sets and is designed for performance and scalability. So several software editors have already developed capabilities to share 3D models to ArcGIS Online and ArcGIS Enterprise as scene layers. And there's another thing for those who've not attended the plenary that I'd like to share with you. So let me ask you a question. Who does not know who is the Open Geospatial Consortium, often called OGC? Everybody knows. Fantastic. So just as a summary, OGC is an international industry consortium of over 527 companies, government agencies and universities that defines open standards for the geospatial industry, aiming for greater interoperability. And I'm very happy to share one more time that a few weeks ago, the OGC has announced that the scene layer is now an international OGC open standard alongside KML, WMS, and CityGML, to name a few. So we've talked about creating content, visualizing information, sharing immersive 3D scenes, but what we really want to do is to find solutions. Well, we want to solve business problems. We want to save costs, reduce environmental impacts, improve people's life. We want to do our work better. And if you ever need ideas on how to do all these things with maps and scenes, I would like you to explore solutions.arcgis.com. So you will find projects, data models, geoprocessing workflows and symbologies, application source code, and more, and all of them are configurable to work with your data and adopt your business logic. So in fact, there is a very good public story map that articulates the business value of 3D GIS solutions called Solutions for 3D Base Map and Development Review. So it brings us through the use case of planning for a new development and the assessment of its impact on the existing environment. So here's an example of a visibility analysis telling us how much of the marina can be seen from each of the building, including the new proposed development. The solar radiation analysis is particularly useful to plan for sheltered pedestrian pathways and placement of solar panels. And the shadow analysis, this one was solar radiation, sorry. And the shadow analysis helps us understand how this new development is going to cast shadow on its surrounding. So, and the most important, who knows that these solutions are covered by the Esri support? I do. Anyone? No. So if you ever find something that does not work as expected with one of the solutions, just send an email to our support and we get it fixed for you. Do we have developers in the audience? 1, 2. So you'll be happy to know that with the release of the ArcGIS API for JavaScript 4 and ArcGIS Runtime's SDKs 100, developers now have first-class API to work with 3D content and services. So let me show you some example of web application developed with the ArcGIS API for JavaScript. So this application helps us review buildings according to height and time. It helps us enhance the visual experience and mining for information in large real-world data set. So although viewing scene layers on mobile devices is still in beta, it works. So with the latest ArcGIS API for JavaScript, all your 3D models, analysis, and operational information are accessible on mobile devices without plugin. All right, that's all I have for you today. I hope you've learned something, and I will hand it over to Zara, who's going to present us the road ahead. Thank you.
All right. Thank you, Tibu. Great. So these are the items that are definitely in the pipeline for 3D and ArcGIS. And these are our solution mix that we have presented in this afternoon session. As for the training, so we have an upcoming ArcGIS Pro training in October 5th and 6th. You can check out the Esri Singapore site for that, as well as the resources.archgis.com page for the solutions for 3D base map. And with that, we would like to thank you all and have a great afternoon.